Okay, YouTube, this is my first in a series of videos that I'm doing over exponential functions in which we are going to define what we mean by an exponential function. So let's go ahead and proceed with this here. We say that the exponential function f with a base b is defined as f of x equals b to the power of x, or y equals b to the power of x, where b is a positive constant other than 1. And we say that b must be greater than 0, not 1. That's what this says right here, basically. And we say x is any real number. So the interesting thing about this function here is that when we talk about exponential functions, we refer to this bottom number here as the base of the exponent. And you'll notice that our variable is in the exponent, So in this particular case, this is different from functions that we've seen in the fact that the variable is actually up in the exponent and the base is a well, let's put it this way. It is a, I want to write non-zero constant. Let's just say a positive constant. A positive constant. Okay, constant is what this is here. And this is just our y value over here on the left. But basically, if we have y equals some positive constant to the power of x, then we have an exponential function. Now, one thing I do want to say about this is b is not allowed to equal 1. And so the reasoning behind this is, just explore this with me here. If you had y equals 1 to the power of x, anything to the power, or 1 to the power of anything, that is always equal to 1. So you can see that these two things here would be the same. And so that is why we don't allow 1 to be our base, because this is not exponential. Okay, exponential functions have they have positive constants to the power of our variable here. So we say examples of some exponential functions are these that you see here. So on each of these we say f of x or y equals some positive constant to the power of some variable expression. So we say 2 is a positive constant to the power of x, or maybe even 10 to the power of x, where 2 is our base here and 10 is our base here respectively. Our bases over here are 3.5, and you'll notice that we can have, say, x plus 1 in the variable, or in the exponent. It's still a variable expression. We can have x minus 1 in the exponent. But these are all exponential functions. Now, it says down here, by contrast, the following functions are not exponential functions. So let's start with this. F of x, capital F of x, is x squared. So now you'll notice that the variable is the base. And what I want to tell you is it's only exponential if the base is a positive constant that's not equal to 1. So we'd say that this is not exponential. As a matter of fact, this is something else entirely. This is a quadratic thing. Now next door, you might say, well, this is a positive constant and we're taking it to the power of 1, but we also said that this is not exponential because the base cannot itself equal 1. Otherwise, we'd have this function just y equals 1. Now h of x equals negative 1 to the x. The thing here is this. We cannot have a negative base on this. And the reason why is because if you were to look at a table of values, we say here's h of x, and we say 1, 2, 3, 4 here, and we plug these in, we'd have negative 1 to the 1, negative 1 to the 2, negative 1 to the 3, negative 1 to the 4. And you can see that every time that this is an even thing, this comes out to be a positive 1. Every time this is an odd thing, it comes out to be a negative 1. So we wouldn't get something that behaves like an exponential function. And then last but not least, this cannot be an exponential function because we can't have a variable in the base. Remember, it has to be a positive constant that's not equal to 1. So what we're going to do is we're just going to take a look at an instance where we would use an exponential function. It says the data in figure 4.1 can be modeled by the function here. So we say y, or f of x, equals 42.2 times 1.56 to the x power. So we're going to fill in a few things here. We say f of x is the average amount spent. I'm going to write this in. We say the average amount spent, and that is being measured in dollars. And we say that x here, x is the time at the mall after x hours. Okay, so we say let's see, the average amount spent in dollars at a shopping mall after X hours. So we'd say this is time in hours. So all of our points here, we're basically going to say is a time and then an amount of spending. Average amount of spending is our y value there. So what we're going to do here, there we go. Average amount, let me see if I can slide to the right here. Spending. And that would be our y value on our point here. So now what I want to do is this. I want to use the exponential function that we're given here to find the average amount spent to the nearest dollar after 3 hours at a shopping mall. And I want to know, does this rounded function underestimate or overestimate the data that we have over here? So basically what I want you to notice is this. I have given you an average amount, or excuse me, I haven't given you an average amount spent. I'm asking you to find the average amount spent, but I've given you a time. And so at this point, what I've done is I've given you an x value, we say 3 hours, and what I want to know is find the y value when x equals 3. So we're going to say if x equals 3 after 3 hours, what is the average amount spent right here? And all we have to do is just go plug this into the function. So really quickly here we say f of 3 is this 42.2 times 1.56 to the third power. So what this really truly means is we're going to take 42.2 times 1.56 3 times. But the nice thing about this is if you just turn on your calculator here, we could type in 42.2 times, and you know what, actually I'm just going to write in parentheses here 1.56 to the power of 3, and we should get a value here. Now we said to the nearest dollar we'd say about $160 what I put right here. So it's approximately 160 right there, 160. And so we could say it'd be about $160 is the average amount spent after 3 hours, okay? Now looking at our picture over here, we say after 3 hours, they actually got 149. So our model overestimated the data by, let's see, this would be 160 minus 149 by $11. Cheers.